Alright, so now that we're done with a lot of the essentials of what we need to create for a horror game, I thought we could work on a few things that are just a bit more fun to recreate some popular and unique horror mechanics from well-known games, starting with the camera from Outlast. So essentially, recreating the camera is mainly just about changing our post-processing effects, adding a HUD for the camera, and giving us the ability to zoom in and out. So we can start with the HUD first. So let's go into UMG. And actually, before we create a widget, we actually need to import textures, just something I created in Illustrator really quick, which will be available for download. So if we go into textures, I'm just going to hit import, find my location, and just import the two. I have this camera box and this camera record button. And we can go ahead and open these, and I'm just going to, compression settings can be user interface, and texture group can be UI. It's fine for that one, and just do the same for this one here. User interface for compression settings, UI for texture group, and since these here are straight lines, I'm going to change the filter from default to nearest, and that'll give us much crisper lines. I don't want to do that for the camera record dot because it's smoothing out right here will look a little better. If you see it in nearest, it's too pixelated, so I'm just going to leave that on default. Okay, so I'm going to go back to content, UMG, and we're just going to create a new widget blueprint. I'm going to call this W camera. Open that up. And we just have to make this look like a camera. So maybe I'll add some text in the bottom left that says 1920 by 1080. And negative 120, and then maybe in the upper right we'll add a horizontal box with an image inside of it, and this image will be our record dot, and let's make the image size 36 by 36, and then we'll add some text next to it in the horizontal box that will just say rec for record. Maybe add a spacer in between those with a X size of 10 to add some space. Let's make that record text red. That's the shadow color. Okay, horizontal box, let's anchor it to the top right, negative 100, negative 200 maybe, 120, something like that. And let's make this size Y 36, so the circle is a perfect circle. We can also add the image of the camera box, which I'll just drag in the center. Camera box. We'll make the size 250 by 250. We will anchor it to the center. Alignment 0.5 by 0.5, and then we can position X, Y, 0 to make sure it's in the center. And let's make the opacity of this something like 0.6. Alright, so that looks pretty good for now. You can customize this as much as you want. We can also add a little animation for the record button to give it some life. So if we select the record button, I'm just going to rename it to record image. And then we hit animation, and we can just call this rec image flash. Go to the timeline, select rec image flash, and we need to add a track. And since we have record image selected, it'll pop up right here. So we'll choose that. And then we can choose what subtrack we want, and we want the render opacity as a track because we're just gonna have it fade in and fade out. So at 0, we'll have a render opacity of 1, so we can add a keyframe right there. We go to 0.75, we'll make this 0. And I think it should add keys automatically. And then we'll go to 1.5 and change it back to 1. But we're gonna make the length of the overall animation 2 seconds. So add another keyframe right here at 2 seconds with the opacity of 1 so that it stays at full opacity for half a second. So let's check this out. Let's loop it by hitting this button right here and hitting play, and then we're gonna deselect it, and we can just see it up there, and that looks pretty good. So let's go to the graph, and on event construct, which is the begin play essentially, we can just get this rec image flash animation. We can type play animation. Start time can be 0. Number of loops to play is also going to be 0, which means it'll play indefinitely. Play mode forward, playback speed, you can mess with if you want it to be faster or slower, and that is all good. Alright, so let's go back to our L1 character and the event graph, and essentially just what we want is to be able to pull out the camera when we hit a button, which we're going to assign to R. So let's go to Edit, Project Settings, Input, and we can add a new action mapping, and we will call this camera. And do we want on an R? Crouch button is left control. We can make it C, I guess, because I don't think anything else is using C, and that makes more sense. Thought we were using crouch for C for a minute, but we're not. Alright, yeah, we're gonna go with C. So we can just hit input camera. Now it should come up. And what we want to do is, first off, put the widget on our screen, but we're going to actually create the widget in our initialize function. So let's open up initialize. We can add a pin here, or actually, let's do it off then 1 where we already create the main HUD widget. So we'll create another widget. And the widget we want to create is wCamera. And we're going to promote this to a variable. And we'll call this camera widget ref. But we are not going to add to viewport because we don't want it on the viewport quite yet. So back to the event graph, input action camera. Right now we're just going to use a flip-flop, which just means it does A, and then when we press camera again, it does B, and it switches forever. But you can switch this out with a boolean. Actually, let's just go ahead and create that boolean. So is in camera as a boolean. Default should be false, and then we'll just create this as a branch, and that's probably usually the way you're going to want to do it. So if you're not in the camera, we will set is in camera to true. We want to get the camera widget reference, add to viewport, get the main HUD reference, remove from parent, which will take it away from the viewport. Actually, instead of removing it, let's set it to hidden. So set visibility, and let's do hidden. And then let's reverse it for the true. So let's copy and paste. Is in camera will be false right here. A camera widget ref, instead of adding to the viewport, we will remove from parent. And then we will set the main HUD ref visibility to non-hit testable self only. So we can actually test that out now. When we hit C, it should switch our main HUD widget right here to our camera widget. Alright, we're now in the camera widget. We've got our animation playing in the top right. We've got our box in the center, and so far that's the only thing that changes. we'll hit C again, and it switches back. Perfect, that works really well. All right, so now let's add our zoom functionality. So we'll do this with 2 inputs. So edit product settings, input, and we're gonna add 2. This one will be zoom in, and this one will be zoom out, and zoom in will be mapped to the mouse wheel up, and zoom out will be mouse wheel down. And an L1 character right beneath the camera, we'll add input zoom in and input zoom out. And we're just going to be changing the field of view when we zoom in and out. So we need 2 variables for the minimum and the maximum field of views. So I'm going to create the first one called min FOV, and it's of type float. And the next one will be max FOV. Let's compile and set these. The min is going to be 30 degrees, and the max is going to be whatever our default field of view is in our character. So if we go to initialize, we're just going to put it in here, off of then 3, pull these out so I have room. I'm just going to set the maximum field of view to our camera and get field of view. Because we don't want the camera to get a wider view than our human eyes. So if you ever want to change the camera's FOV, you don't have to worry about changing this variable as well. All right, so let's do zoom in first. We just have to make sure we are in our camera to zoom in. And if we are, we can just get our camera, set field of view, and we just want to get our field of view, and we want to add 5 to it. You can change this, you can make this into a variable if you'd like. This is just how fast and you'll zoom in, but 5 is something that works for me. And then we want to clamp it so it doesn't go above or below the minimum and maximum. So max is max FOV and min is min FOV. And we actually have to make this 5 negative 5 for subtracting, not adding. Negative 5. So let's copy and paste this to the zoom out. And instead of adding negative 5, we're going to add positive 5. All right, so let's test that out before we continue. So let's hit play. If I move the scroll wheel, nothing happens because we're not in our camera. I'm going to pull out our camera with C. And now when I scroll up, we zoom in. And we can't zoom in more than 30 degrees. And if I zoom out, we zoom out, and we can't zoom out farther than our normal view. So we can now zoom in and zoom out, which is great. But you'll notice if I zoom all the way in and then I leave my camera, we are stuck at a 30-degree view, and we don't want that. So in L1 character, after leaving our camera off this true path here, we want to set the camera's field of view back to our default. So set field of view, and the field of view we want is going to be our max FOV. And lastly, we just need to make it actually look like a night vision camera, because we got everything else so far. We can see that it resets our field of view when we go back, but we want to make sure it looks like it's night vision, and we'll do this with post-process settings. So we want to add another post-process volume into the world. So post-process volume, drag this out. It doesn't matter where it is. And just to be able to test what this one looks like, I'm gonna take our first post-process volume and I'm gonna turn off unbound so everything gets reset. Then this post-process volume will take priority, because for this one we do want to check unbound. So now we're seeing what's happening in this post-process volume 2, which I'm going to rename to post-process volume Outlast Camera, and I'm going to put that in the rendering folder. So first off is the exposure, like always, except instead of setting it to 1 and 1, I'm going to set it to 0.5 and 0.5, so it's a bit brighter than our regular view, so because it's a night vision camera, so it should be able to see a little better. And before we change the other things, let's go ahead and match the first post-process volume things that we are not going to change, such as the motion blur. So let's see, I set the motion blur to this one at 0.7, so on this one we also want it on 0.7. The chromatic aberration I'm not going to change, so this one we set it, oh, did we not set it in this one? I thought we did. Chromatic oh, we did. Intensity 0.3, intensity 0.3, and now we should give this a green tint. So if we go to color grading and miscellaneous, right here, misc, we have scene color tint. We can check that and we can tint the scene. So we're just gonna make it fairly green. We want to up the bloom, or just so it fringes the light a bit more. I want to add more of a vignette, so that is right here, vignette intensity. I'm going to change this to 0.8, and I'm going to up the grain a lot, so the intensity I'm going to put at 0.7 and the jitter at 0.6. Okay, so we can hit play, and this is kind of the view we'll be getting when we're in the camera. I'll switch to the camera mode, so this is kind of what it looks like. So we just have to make it so it switches back and forth when we come in and out of our camera. If you want, you can also go to the slope and turn this down a bit just to, you know, brighten up the scene. So maybe like a 0.5. Because it is a night vision camera, so you want to be able to see things a bit easier. I think that definitely helps with the Outlast look of it all. Alright, so let's set this first post-process volume back to unbound, and let's set this one as disabled, so just disable a volume. So this is, we're just back on our regular post-process volume at the moment. Back in the L1 character, let's create an event dispatcher here called toggle post process. Now let's give it an input right here called camera bool, and it will be a boolean. Event dispatchers kind of work like blueprint interfaces, where they can be called from other blueprints, but dispatchers work more specifically to one blueprint you're trying to reference, rather than kind of a global can be assigned to anything, if that makes sense. So I'll just show you on the camera. When we press it, we want to call it after pulling out our camera and setting those settings. So we'll drag this out and we'll hit call. And when we call it here, we want to check camera bool because we want to change it to the camera post-process settings. And then we'll call it again when we put away the camera, and this time camera bool will be false to go back to the regular settings. And now let's go to the level blueprints, open level blueprint. And in the begin play, we have to cast to the L1 character. Let's get player character, cast to L1 character. And from here we can assign, I'm gonna close the widget, we can assign this dispatcher. So we will call toggle post process, and we have these options, and we're going to hit assign toggle post process. So this creates a node and a custom event. So we're just going to call this toggle post process event. So this event here, we have to leave this connected. Essentially, every time that this is called, this event will fire. And we do it from the level blueprint so we can reference these process volumes. So we have the default one, which is our global, and just have it selected. Right click and create a reference to post process volume. And let's do the same with the camera post process volume. Right click, create reference. And we just have to set these enabled and disabled accordingly. So we will set enabled. And if the camera bool is true, that means we want to use the camera post process. So we're just going to put a not boolean into here. So if camera bool is false, this will be true. And if it's true, it'll be false. And we'll do the same with this one, set enabled. And we'll just plug in camera bool directly without the not boolean. So now it'll switch between the two, depending on whether this camera bool is checked or not. So we press input action camera, we open our camera, we add the widget, and then we call toggle post process with camera bool checked, which disables our post process volume and enables the camera one, and it does the opposite when we close the camera. So we can test this out. So we have our normal post process volume going on here, and when we hit C, it should call the event dispatcher, go to the level blueprint, and switch the enabled between the two volumes. And it does. Now when we open our camera, we have our Outlast Camera post-process volume. And when we close it, the same thing happens. Alright, so that seems to work perfectly, and it looks really good. The result is amazing. Alright, so that'll be it for this episode. I will see you in the next one.